Have you ever wondered how deep tech companies actually start? Well, we were too.
So in this podcast, we'll be interviewing scientists and entrepreneurs that have taken their ideas out of the lab and turned them into startups. I'm Antonia.
And I'm Christina, and this is Startup the Science. Hello, and welcome back to another episode of Startup the Science. And today we have a lovely woman.
That's right, named Laura Bücherle,
who is the co-founder of Ghost Feel It.
Yes, we're very excited to have them because they are the first ever haptics startup that we have on our podcast. They do really cool things, and Laura's going to tell us more about it, but to prepare you for what's coming, they are working on human-machine interactions, basically, by using non-invasive technologies. So it doesn't require any surgery. You don't have to implant any chip under your skin or anything weird like that. But their solutions can be applied both in the medical device sector as well as other industries, and she'll tell us more about it. But we think it's kind of cool.
Really cool. And the software that they're working on is so cool because they're basically putting into a database the entire haptic language.
Which is very cool. So basically what we understand that they are trying to do, it's always like this. We always think we get it. And then they're like, not quite. But from what we understand, they're trying to put together a database of haptic language. So what do the different gestures and different things that we might be able to do with our body
and feel.
Feel. Yeah, how do they translate into feelings, and how can technology make that translation? I think
I just thought it was just going to be a database of like different types of vibrations.
See, we're not really sure. It's good that we have Laura on the podcast. She can explain. But what we wanted to emphasize is that they work on the hardware, but also the software, and they're transitioning now more to the software. Yeah.
Very cool startup.
Very cool startup. So here is Laura. Hello, and welcome to Startup the Science. Very nice to have you here today with us.
Thanks for letting me be here.
It's our pleasure. So you're actually our first haptics startup that we have on the podcast, which is great. We've had an exoskeleton startup before, Motorskins in season 1. And I think this is a very nice sort of follow-up to that. Let's start a bit by talking about the field of haptics, which sounds very sci-fi, right? There are a lot of applications in it, gaming, options. There's medical technologies that could benefit from it. But you can tell us more about it, I'm sure.
Yeah, so basically haptics is a new or up-and-coming area that most people just know about by from their phones when it starts vibrating when you get a text message or you get called. And they're mainly used as warning or alarm signals. And there's a lot more potential that you can have in those vibrotactile feedback systems. And so I'm really happy to be here and talk to you a little bit more about it. The industries that are mainly focused on it is, so for one, of course, phones, smartwatches, tablets. And then on the other hand, there's like gaming. So you mentioned it as well. So all the Sony controllers when they really freak out when you get shot or run away or whatever you do, or VR training, or also in automotive settings. There's a lot of potential, a lot of things done to make people not only see and hear what machines have to say, but also feel it.
So it's very interesting because it's a technology focused on feeling, right? Rather than focusing on any other senses. And I think, well, at least the way I understand it so far, there are applications of it that have more to do with entertainment or enhancing your gaming experience, for example. And then others that have more to do with safety or medical applications that are more helpful, let's say, rather than entertaining.
Exactly.
Right.
Yeah.
So tell us a bit about what you guys do. Yeah. When it comes to Ghost, which ones are you focusing on from all these many applications?
So basically we focus on giving an additional experience. So it's not only about when you have, for example, a VR setting, that you want to mimic something that is happening in VR to make it feel like it is happening to your body at the moment. But you can also broaden different perceptions. So you can, for example, make you feel like the dress that you're just now drafting in a VR setting. Or so you can have a different dimension of feeling or creating a new sense, for example. And that is a very futuristic use of haptics and tactile feedback systems. But of course, it can also just mimic something. So for example, when we started originally, we had this idea of creating a prosthesis that could make people feel whatever the sensation in the lost hand was in order to for one, reduce phantom pain, but also increase the functionality of the prostheses and making you feel whole again, right? Like not like you had lost the hand. And that's something where you can take up all the information that kind of come into the prostheses, like finger bending and pressure sensations, and you can put them on another part of the body, and your brain will be capable of learning how to feel your hand on your back using those sensations.
Wow. That sounds so interesting. It's also very hard to imagine somehow for me because it sounds very I don't really know what the word for it is. But so you're missing, let's say your arm, right? You have a prosthesis, and then you would feel the sensation that you would normally feel in your arm.
Yeah.
But in a different part of your body.
Yeah.
And then those signals would be sent to your brain.
Yes.
And this is how you, okay.
Exactly.
Sorry,
So
I'm trying to break it down like a dummy just to understand.
But if you think about it, that sounds really like futuristic and you're like, what? No, that can't be happening. But if you think about it, just one point at a time. So you have a pressure or a point, whatever, a pressure point on your finger, on your index finger, for example. And every time you press it, a vibration motor on your shoulder turns on. And you press it again, and it turns on again. And then after a while, obviously, now you can imagine that if you press it and you don't look at it, so in theory, you wouldn't feel it, right? You would still feel the vibration motor on your shoulder turning on. So in a sense, your brain already learned how to look for that sensation of the vibration motor turning on when you have your index finger experiencing pressure.
So it's like learning through association, right? You associate this.
Yeah.
Right.
Exactly.
You associate these sensations that are normal, they're not naturally, let's say, associated by default, but you rewire your brain to associate.
In that application, definitely. Yeah.
That is so cool.
But then there are other applications. For example, if you think about automotive situations, you can also have a bit more intuitive ways of using haptics, because in the scenario of a prosthesis, people already have to learn how to use the prostheses because it's not extremely natural at this point anyway. So they're willing to put in the time to learn how to feel, how it is felt. In a car situation, people want to sit in the car and already know what is happening. So they don't want to spend the training time to actually learn it. So there you need to have very intuitive feelings transmitted. So for example, if you have something tapping on your shoulders, then you would be very likely to just intuitively look left because you were just tapped on the shoulder. Or if you can have some kind of swiping sensation that would maybe cause the same effect. And so that way you can kind of play with those haptic feedback systems, with those touch system feedbacks, and make people intuitively react to those feedbacks.
That's really interesting. So part of your job then, if you were to design those systems, is also to figure out what sensations feel natural and create an instinctual reaction.
Yeah, so we basically built a database of basically incorporating different actuator types, so different motor types and different location scenarios on the body over a different timing, how they're turned on, for how long, in which amplitude, which frequency, to find out what feels natural. And for that, you can make, for example, recreate movements or evoke movements like looking left, looking right, kind of putting attention on different body parts, but also causing emotions, for example. So you can mimic body biofeedback, so you can calm down or you can make people be more excited. Yeah, so that's basically, or generally, like what we had in the prostheses, different encoded signals that could mean something, that you could learn, right? So that's the thing that we spend most of our time on, creating the database of those haptic feedback systems.
It's like a haptic language.
Yes, exactly. So we basically create a haptic language.
So it's like a language, like it's like a library of sensations and emotions.
Yeah.
That's really interesting. And then depending on what the goal is, right? So in a car system, I'd imagine many of these applications would be around safety, right? Or around safety and comfort, maybe in a car.
Yeah. Right. Because in a car especially, I mentioned earlier that there are basically only three ways machines at this point can talk to humans. You can see something on the screen, you can hear something from a speaker, or you can feel it through, for example, vibration motors. And that's, I would say, the three main ones you can use, because smelling and tasting might not be a good interaction for normal machines. And especially in a car, just think about what is going on. So you have to drive on the street, you have traffic around you, you might have bicycles and pedestrians, you have instructions from your navigation system, you have the radio, maybe you have some passengers. You have to check what speed you're going. And so you have a lot of influences that come in visually and through audio channels. And basically, if you want to alert or inform the driver of things outside of what you already experience, turning on another lamp or another alarm signal might not be the right thing to do.
Right, because your senses are already overloaded.
You're already overflowing. Yeah, exactly. So switching to a new channel to talk to the human in that scenario is a huge benefit.
Amazing. And I know one of your applications that we had discussed at some point with the company as well was the idea of calming down the driver in a stressful situation.
Yeah.
Do you want to talk a bit more about that or about that concept in general, how that might work?
Sure. So we introduced a concept of calming down what you said, the drivers in stressful driving situations, by mimicking biofeedback. And your heart rate you will try to adapt to it, like you do to music with a steady beat. You try to naturally adapt to it without even doing anything. So in a stressful situation, you would not freak out or react in a stupid way. You would react really controlled because you are in control, and your body feels like, no, why am I feeling stressed? I'm okay,
So it's a way to kind of trick the mind to calm down.
Exactly.
So you can react better. This is really cool. And I think one of the most fun things about recording this podcast that we find out about these really interesting ideas from very talented founders. How did this idea start? How did you and your co-founder decide to start Ghost? How did you meet? Tell us more about that.
So Isabella and me met in high school. We actually,
a long-term relationship.
Years ago. Yeah, exactly. A long time ago. And we were partners in crime for a long time there. And then we kind of went our separate ways. I studied biomedical engineering, or first engineering science in Munich. And then I went to Glasgow, did biomedical engineering, and then started working for a sensor company here in Berlin. And while working there, Isabella, on her path, went to study psychology and then neuroscience, and then decided to do her master's degree in industrial design in Munich. And we caught up over the years. And she had this idea and told me about it at one point when we met, that it would be possible to, and now I kind of spoiled the story already because we talked about the prostheses, to recreate feeling of a missing hand on a different part of the body, like your back. And I said, in theory, it is possible to build such a technical device that would be capable of doing that, but I don't think the brain would be capable of doing it. And she said, no, the brain is definitely capable of doing it, but I don't know if we can build such a machine. And so that's kind of how we started together and kind of proved each other right in the end.
It's very good. Yeah. Excellent. And who else did you bring then on your team? What other things did you need to make your team full or whole, I should
say? Since we had to also build prototypes for the projects that we talked about, we had Wei helping out. She's a biomedical engineer as well. We brought Ben and Dominic on board, who both work in software, because we are now shifting to creating a software solution, kind of Photoshop, but for haptic interfaces. Yeah, so we needed some more software experience, and we have Jocelyn on board, who's doing interaction design.
Very nice. So what are you guys working on now? What are some of the projects that you can talk about? I'm guessing some of them might be in secret mode for a while, but which ones can you tell us more about?
So most of them I cannot talk about.
Well, this is the end of this episode.
Yes. The one that you can even live experience is done in this year's batch from the Startup Autobahn that we're participating. And we did a project with the research and development party of the Mercedes-Benz AG. And I don't know how much I can talk about the project, but if you are around, you can definitely come by to Stuttgart and have a look while we present it, and you can even have a test drive. But the one I can talk a little bit more about is that we did a project with the TU Berlin last year that was about comparing visual feedback in a VR system with haptic feedback in form of a haptic belt. So they published a study that is not yet published, so I can't go too deep into the details. But basically, it showed that rowing novices were capable of coordinating breathing and movement faster by receiving haptic feedback than by pure visual feedback. And that's one of the studies. I mean, this is, for me, this is like mind blowing. It's like, wow, haptics can speed up learning. It's like, why we're not doing this for everything.
It is really cool.
Yeah. But for Isabella, for example, she is very used to it. It's like, yeah, of course. Like, the more channels you use, the better you learn. This is apparently very well known in everyone who deals with the brain. And
it's really interesting because I think by now, most people know that different people learn in different ways, right? Yeah. There are people that learn better when they listen to podcasts, for example, or they listen to audiobooks, and others that are more visual learners, like Christina here, for example. But I don't think I knew either that you can also be what would you call this?
A kinesthetic learner.
Yeah, kinesthetic learner? Yeah, or like a touch learner?
I think it works best if you have, the more you have, the better you learn.
Any particular wishes that you have that you would like to talk about? So if your startup could have 3 wishes granted right now, magically through the medium of a podcast, what would they be?
So basically, I mentioned earlier that we shifted a little bit our focus from creating those concepts to basically show what haptics can do and what we can do, to creating the software that other people would be able to creating those haptic feedback concepts themselves. And that's a big step because you need a lot of different competences in order to create them and create them well. So that's why we want to create this database with the software environment, basically, to basically dip into the database and build and pick and choose the right patterns for your application, so that you can build it yourself rather than going to the few people who actually know or have all the competences in the team already. That's extremely important, especially because there's not that many people who know haptics that well. I mean, you cannot study it. There's, I think, only 3 programs, university programs in the whole world that offer haptics. So you cannot start by having students that come from the field. Yeah. So you have to kind of learn it and experience it. And this is something that will change over time. But for right now, we want to enable it to be used not only in smartphones, but also in other use cases. And that's why this is really important. So coming back to the 3 wishes, one wish would be, because everywhere I go, we first have to explain a lot about haptics, and then we can be like, and so the problem that we are solving actually deals with creating those interfaces. So it would be great, for one, that more people knew about haptics and the potential it has, like, for example, the speeding up learning ability or and what it can be used for. Second wish, we are right now, this month we started the APX Accelerator, and we are really working on our business model, challenging ourselves, starting from scratch, to see what actually makes sense and to prepare us for our seed round that we're planning to raise investment. So second wish would be finding the right people to invest in us who share our vision of haptics being a big thing in the future and not the very far future as well.
So what would be the ideal profile of an investor if you could pick your favorite imaginary investor?
So ideally, they would support us not just now, but also as like a long-term partner to stand by our side. They would believe in the haptics market, and also, I mean, this is not something that we usually point out, but we are a co-founding team of only females, and it is sometimes still the case that you're not trusted as much, we feel like, as if we were also, or if we were male or we had a male co-founder as well. So that's just something that I guess is a bias. So somebody who's not biased or who believes because we are women, we are the best for the job.
For sure. I mean, we try not to hyper focus on that when we interview women, because if it's not a problem, you don't want to create it. But it is a problem for sure in the industry.
Yeah.
And when you see women in tech, many people have initially a slight reaction to that. Maybe they're slightly surprised. They don't expect to see a woman leading a company. So yeah, you would need to have investors that are not thinking like that.
Yeah. I'd say most of them are not. Just saying.
Yeah.
Ideal investors don't. But
yes, of course. Wonderful. Well, hopefully those wishes will come true. There's a third wish. Yes, sorry. We missed.
Third wish.
You have a third one.
Oh, God.
Can be a personal thing as well. Like if you want something as a present.
I'm
joking.
A present. No, I don't know. I feel like we got a good team. We know where we're going. Having some investment, having the right people. I mean, obviously, we're always looking for business partners or business partners who want to join us on the story. Or if we find customers who already are interested in having this software, then obviously come and reach out. We are more than happy to talk about it and how we can support. And yeah.
Wonderful. So we'll put all of your contact information below. And you're based here in Berlin?
Yes.
So if anybody wants to come and see you, what part of Berlin are you based in?
We are. We have a mentor from the Free University in Berlin, and so we sit in their startup house.
Nice.
So
one final question: what does Ghost stand for? Ghost Field stand for? And how did you come up with this name? Because it's a cool name.
So originally we started with the prostheses, and there we thought what would be a good name that can describe it, and we came up with Phantom. But then we thought Phantom is maybe a bit negative, and it didn't quite fit. So we looked for an alternative, and somehow we ended up with Ghost because it is something you can feel, but you can maybe not see. And also because we were big fans of The Ghost in the Shell. Don't know if you know the movie or the anime. That represents basically giving machines a soul. And we like to think that we're doing the same thing. We are giving a soul to the machine because it is a new way of experiencing, and it's a lot more personal than, I don't know, audio or visual feedback.
That's really nice. I like that, giving machines a soul. Maybe that could be a nice tagline. We'll put that in the description of this episode. Thanks a lot for being with us, Laura, and we'll see you soon.
Thank you.
Thanks for listening to Startup the Science.
If you like our show and want to know more about what we do, check out our website at inam.berlin.
And don't forget to leave us a review. Until next time.